Assalamualaikum and a very good day. So, okay, I would like to show some demo on how to use another simulator which is called TinkerCAD. Okay, the purpose of we are also use a TinkerCAD instead of multisim is because TinkerCAD is more close to physical experiment. Because okay, the question is why we need to do both multisim as well as TinkerCAD on the same experiment. It is because if you talk about the one that close uh, to physical experiment is a TinkerCAD, but we also need to do the experiment using multisim is because the accuracy of the result in multisim is better than TinkerCAD, especially for experiment 1 whereby you need to use the oscilloscope, and if from the oscilloscope you produce a graph, and then from that graph you need to measure the voltage according to tau you have calculate. So that features you can only access on multisim, but you cannot access on TinkerCAD. So that's why in for this semester you need to do both from the given circuit you need to do both using multisims live as well as TinkerCAD. Okay, almost TinkerCAD is almost similar with your multisim live. It's a online apps, so you don't have to install. Just go to the tinkercad.com, and then you need to sign up and register your name. Is still and once you register, this simulator is also free. So what you need to do is you go to the circuits there. Okay, you just click the circuits, and then once you click the circuit, then you can click create new circuit there. Okay, so you can see that the components in TinkerCAD is close to your physical. As you can see, resistor is like resistor, and you have a button, you have a LED, and so on. So that's why I said before, then the TinkerCAD is more close to the physicals as compared to multisim. And of course, in order for you to build any circuit, you need to build on the top of what we call as a photoboard. So what is photoboard? Okay, photoboard is also known as a breadboard in this simulator. So you just can type over here breadboard. Okay, so then this is an example of breadboard there. You just choose one of it. I just use the small one or the mini one, so you can choose any of it. I just choose the breadboard small there. Okay, I just press hold, and then I drag into this simulation area here. So this is your breadboard or photoboard. So you can see before we talk about how to build the circuit, you need to understand the characteristics of your photoboard or your breadboard. As you can see, if I play around with my cursor according to that all holes there, you can see that there's a green line. Okay, there's a green line appear. So that means, okay, in a physical photoboard as well as this simulator, you can see that this green line here represent the built-in wire which cross over all these 5 holes, meaning that this point is connected with this one, this point is connected with this point, and this point connected with this point as well as this point. So same go to other side of point here. Okay, everything is in that type of architectures. But if you go to the most upper side or bottom side, you can see that the connection in that way. Okay, means that from here to here, all point is connected together. From point here to here, all point is connected together. So what is the purpose of design the photoboard or breadboard in this way? That is because the purpose is that they want you, okay, because in practical, by having this kind of architecture, you can minimize of using too many jumper to design circuit. Okay, let's say you have a very complicated circuit, then if you know that this photoboard have their own built-in jumper or built-in wire inside this photoboard, then you can utilize it. You don't have to use too many wires, and otherwise you will, very difficult for you to debug your circuit. Okay, because too many wires, too many connection. So that's why you must utilize this jumper or this built-in wire, so you don't have to use too many wires to build the circuits. Okay, for this demonstration, I will not use circuit from your lab sheet. I will use another example, which is this one. Okay, I will demo to you how to use a TinkerCAD to simulate or to build these two circuit. One is a series circuit, another one is a parallel circuit. Okay, it's a normal series and parallel circuit. So you can see that, example, the power supply is 5 volt, and then the resistance is 1 kilo ohm each there, and then the red colors there, the red fonts there show, if you want to calculate by using hand calculation, then you can get the result there. If I want to find the current across this circuit, then it should be equal to 2.5 milliamperes, and then if I want to find the voltage across this R over here, it should be half of the power supply, which is 2.5 volt. Same goes to the parallel circuit. If I want to measure the voltage across this R here, it equal to 5 volt because it take this power supply voltage. And then if I want to measure the I1 and I2, if I using a circuit analysis, I find out that I1 equal to I2 equal to 5 milliamperes. Okay, let's focus on this circuit first. Okay, the series circuits. By using this TinkerCAD, okay, first you need to, of course, power supply, you need to find the power supply. Okay, this is the power supply. Okay, you just create, you just type supply, then this is the power supply. And then of course in practical, normally they will connect into these two line, because normally this is the line that we use it for power supply. Actually, it doesn't matter how you build the circuit on the top of this photoboard. You can do whatever design you have, but I just show you in practical. This line over here and this line over here normally is used for supplying the power before you can create the circuit on the center side over here. So that's why I will connect my positive terminal over here into positive terminal over here. Okay, you just can draw according to okay, you just click there and there, and then this is a negative, then you connect. And then again, because our power supply should be 5 volt, then you need to go into, you just click this one. This is the properties. So now it's 5 volt, so it's already 5 volt, so you don't have to touch anymore. Okay, and then after that, of course, the negative will represent the ground. After that, you need to connect this 1 kilo ohms. Okay, you just take jumper, because this one from positive terminal into resistance. So where is the positive terminal? Over here. So you can choose any hole across this line, because it's already connected together, because of that green line, of green line appear inside the hole. Because this one, either you choose this one or this one, it's same as you choose this one or this one, because it's connected together. So I just choose one hole there. I just link with any point over here. I choose row 7 over here. Okay, so now row 7 over here, it's all connected together. Okay, just don't mind, I might confuse you, because now normally let's call it column 7. It's better to call it column 7, because we have that kind of design. So this is column 1, column 2, column 3, column 4, column 5. So this is column 7. So now this hole is originally connected together. This 1, 2, 3, 4, 5. So it's connected together. So now you want to connect to resistance. So you find a resistor. So where is the resistor? So there is a resistor. So oh sorry, you need to click this one to rotate. Okay, so if you want to rotate the device, you click this one. So then I connect into any port over here, any point, any hole in this row 7, because okay, I just choose the last one, that one. Okay, why I choose the last one doesn't matter. You can connect here, you connect here, you connect here, because all this hole is connected together with this point, where this point is you already connected this point, and this point means that they are all connected in wires there. So you're going to the positive power supply, going to that directions, and then going into that direction, and then go across to this R1 over there. So you can see that okay, we already done this one, connected with this one. So how about the other terminal, or the other pin of your resistor over here must connected to another resistor R2 over here. So then this point over here, or this not over here, it's in the circuit, it should be at row number or column number 11 over here. Okay, so what you can do, you can take another resistor. Okay, I just take this one, I just copy paste, so easy for you. So I just Ctrl C, Ctrl V, I get another one. Then I connect to any point over here at row 11 here. Okay, you can put here, any point, because it's connected together by built-in jumper that's appear in green colors there. So I just choose that point, I just choose that. Okay, so this one is some problems there, you can just delete back. Okay, now positive terminals going into resistor number 1, and then to connect resistor number 1 with resistor number 2. Okay, just because the other end of resistor 1 going to row number column number 11, then the first terminal of your R2 must connect to hole of column 11, and then you have the end part of R2 is going to column number 15. So of course, to complete the circuit, as you can see in the graph, you must connect back to the ground or the negatives of your power supply. So you can just take a jumper at pin number or hole that belong to column number 15, then you connect to your negative part there. So then you can just run the simulator by click this one. Okay, of course you cannot see anything because you don't put any multimeter yet. Okay, as you see, let's say if you want to check whether the voltage across this R2 is 2.5 volt, then you need to find the multimeter here. Type the multimeter. Okay, that's your multimeter. Okay, then because you want to measure the voltage, so this is the positive terminal of your multimeter. Then because you want to measure the if you see the circuits there, this point or this node here is belong to column number 11. Okay, like I discussed, what I've discussed before, column number 11 here is actually in the circuit is this point. So that is the point where you need to put your multimeter to measure the voltage. If you want to measure the voltage across this one, the terminal number or the column number 11 is over here. Then you need to connect with your a positive terminal of your multimeter. Okay, you must connect with any point in column number 11 according to this design. So then I just take the positive terminals, then I connect with my column number 11. Okay, while the negative one, according to this circuit, you must to connect with the ground or negative terminal of your power supply. So from the circuit, you know that your negative terminal power supply is this one. Or because this one is connect this one together, you can also choose this one, because this line and this line are connected together. So you can choose either any port of this line or any port of this line. So I just choose one of it. Okay, I connect that. So if I click run simulation, then I can see the reading is at 2.5 volt. So that's how you are using multimeter to measure the voltage.